In this short video, I will guide you through the proper troubleshooting procedure for locating a defective high limit in the gas boiler simulator. Begin by clicking on the thermostat at the bottom right of the page, which will take us right to the thermostat. Once there, click on the system selector switch to turn the unit to heat. This will also turn up the temperature setting, resulting in a call for heat. Our next step is to verify which electrical loads are operational. We can click on the boiler here to take us right to the boiler. Now there should only be two. One would be the circulator pump, the other would be the gas valve opening and lighting the burners. An easy way to follow along is to use the procedure guide at the top left of the page. If we click on this, it will provide us with a systematic approach in a step-by-step sequence. We've clicked the selector switch on the thermostat. Our next step is to determine if the circulator is in fact started. Now you can navigate around and locate the circulator, but it's a lot easier to use the magnifying glass, which will take us right to the circulator pump. Clicking on the magnifying glass, we can see that there is a blue arrow graphic indicating that the circulator pump is running. It's often very difficult to hear a circulator run, particularly if the system is free of air, which it should be. So we know that our circulator is working. Our next step is to determine if the vent damper has in fact opened. So we're going to click on this step and click on the magnifying glass, which will take us right to the vent damper and the vent damper motor. The vent damper closes the flue passage off on the off cycle, preventing the loss of heated air up the flue pipe and out of the building. A simple way to determine if the vent damper is open is to look at the position of the motor shaft. If we look here, we can see that the shaft is flat or horizontal. This indicates that the damper is in the closed position. If the damper had in fact driven open by the motor, this shaft would be vertical. So we've got an issue right here, and this is why our burners are not lighting off. Our next step, before looking at the aquastat and the high limit, we want to click on the wiring diagram tab over here on the top right of the page, second tab down, and just review briefly the wiring diagram. We know that the vent damper, which is located right here, is not receiving power. It's not energized. It's possible that the vent damper is faulty. It's also possible that this high limit switch is open right here. So what we're going to do next is we're going to measure for 0 volts across terminals B and R on the aquastat. Now again, if we click the magnifying glass, it will take us right to this location on the aquastat. The aquastat here is known as a combination aquastat, meaning that all of the components within the control circuit are integrated, meaning we have a transformer here, a relay, and a high limit. On some boilers, these will all be separate components, but this is the high limit right here, and you can see terminals B and R. We're going to take the multimeter out of the toolbox by clicking on the toolbox tab here at the top left. We're going to click the selector dial to AC volts, and we're going to place the leads across terminals B and R. Now, before you do this, take a brief look at the boiler temperature pressure gauge and look at the temperature of the water in the boiler. It may be that the high limit is open because the boiler temperature is between 160 and 180 degrees. If we look here though, we can see that the temperature of the water is considerably less than that, meaning this high limit switch should be closed. Basically, when the water temperature gets to 180, the high limit would turn the burners off, and once the water temperature drops to 160, the high limit would close again and reestablish power back to the vent damper motor and then to the gas valve. So we're going to click the leads and we're going to place them across the glowing hot spots at terminals B and R on the high limit. And we should have 0 volts here if it's closed, but as you can see, we've got 24 volts indicating the high limit switch is open and it's faulty. Again, don't forget to verify the temperature in the boiler prior to doing this. Now on this particular control, this combination aquastat, there's no way to just simply replace the high limit. We have to replace the entire combination aquastat. So we're going to click on the component. We'll store the meter lead back at the toolbox first, click on the high limit or on the combination aquastat, and we're going to click replace. This says that it's going to cost the customer $250, and again, this will be recorded on the invoice, which can be reviewed by looking at this $ icon up here on the top left. We're going to proceed. And as we can see, we've got our stars, 4 stars, so we've corrected the problem. It's been fixed. Last but not least, replace all covers that have been removed during the service call and clean the work area. If we rotate and we look over here in the corner, we can see that the cover for the combination aquastat, which was removed, is here on the floor. We can simply click on that and it will replace the cover. Our last step is to go over in the corner and click on the broom, which will clean the work area. Good luck!
Hey, it is Craig with Interplay Learning. We hope you enjoyed this last video. The easiest way to keep up with all of our latest videos is by subscribing to our page right here. Just to let you know, if you're interested to learn how simulations are critical to onboarding and improving you or your employees' performance in the field, please visit us at interplay-learning.com.